In supply and demand problems, Y is the number of items the supplier will produce or the public will buy if the price of the item is X. For a particular product, the supply equation is Y equals 7X plus 517, and the demand equation is Y equals negative 2X plus 688. What is the intersection point of these two lines? What is the selling price when the supply and demand are in equilibrium? That'll be in dollars. And what is the amount of items in the market when the supply and demand are in equilibrium? That'll be Y. Now, by the way, X and Y, the intersection point we're going to do in this problem in green. X is in dollars, Y is just items. And then the supply equation will be in red and the demand equation will be in blue, like I have shown here. So the supply equation is what we call a positively sloped line. How do we know that? The M value, that is the constant in front of X, is positive. So X increases, Y increases. And that's to say, as the price increases, the number of products that we produce, that we supply, increases. And that makes sense because if we can charge more, we can make more, let's say with our factory or manufacturing or so on. Now notice the demand equation is a negatively sloped line. M is negative 2. That is to say, as X increases, Y decreases. So the demand will be less if the price is higher. And that makes sense because if you charge more, X is larger, for the Y, less people will want the product. Now, what that means is if you think about a graph, there's going to be some optimal where the supply comes up and the demand goes down and the two actually meet. And that's going to be the equilibrium point, the equilibrium price, and thus the equilibrium amount of product produced. And that's going to be the XY point of the intersection. So that's going to be our second method for solving this. Our first method will also show in actually setting these two equations equaling to one another, and we'll just be able to use algebra to solve for X and Y. Let's first look at the second method. So the second method I have shown here using the software program Desmos, that I've got the red line, which is positively sloped, shown here. And notice that I set X equal to be greater than or equal to 0 because we don't want to have a negative price. That doesn't really exist. So also we want the blue line, which is sloping downward, negative 2X plus 688. We want X to be, again, positive or 0, and then Y to be positive or 0, which is to say we don't want a negative price, but also we don't want a negative number of items sold. So notice the blue line slopes down like this. Now notice, what is the intercept for each of those lines? Well, for the first line, it's 517, which is labeled here with the purple point. For the second line, it's 688, which is labeled here with the orange point. Notice the two of them intersect at this point 19, 650, which is what the software tells us. That's the XY point for the price and the number of items. That's going to be the so-called equilibrium point. So this should be our solution. We graph our supply and demand equation and we intersect those two lines. Now, can we get the same answer if we just perform algebra? We can. We just set these two equations equal to one another. So we have 7x plus 517 equal to negative 2x plus 688. In order to do this for the solution, let's add 2x to both sides, collecting all the x values on the left. Thus, we have 9x plus 517 equals 688. If we subtract 517 from both sides, we have, 517, we have 9x remaining equaling to 171. And if we divide both sides by 9, we have x equals just what we saw in the previous 19. And then if we plug that into one of the other equations, we get what we had before.